Hi, this is Neil Bolger of Redcar Analytics, and today I wanted to share a little bit about finding the value of energy modeling in building design. Recently, I gave a little presentation as part of a webinar with some friends of mine about a month back, and I really enjoyed it and thought to expand upon it briefly and be able to bring it to our own friends and family that we get to work with in our business, and also to people I may not know. If you're an energy modeler out there or thinking about going into this pathway, hopefully you find some value and ideas from this brief presentation. So the value of energy modeling in design. So what I really wanted to share today was thinking about how energy modeling really can mean uh, many many different top motivating factors to different building types and different user groups. And every building out there shares all the same goals. They may have the same 20 goals that they would all like to achieve. They would all like to be low energy use. They'd all like to reduce their energy cost. They would all like to be comfortable spaces and have happy people inside of them. Um, Though I always think about who is the actual client for this building, and even if they all have those goals, different clients and different ways people build buildings and then use them, they have different goals that might be more top of their minds, more the motivating factors that really drive them to make decisions as they think about the building they're going to be building. So I've put three examples on screen: public facilities on the left, private built-to-suit buildings in the middle, maybe for a specific user. Maybe it's a corporate headquarters. Maybe it's a courthouse where we know exactly who's going to be in that building. Or maybe it's a private developer who's making a great building on the right, but doesn't have a tenant yet. They're looking for a tenant. And in a public facility, big focus is often long-term energy costs. Many public facilities are now aiming to be net zero energy or very resilient in their operations, and easy to run. So they're looking for robust systems, something that's going to last a long time or simple to maintain. Not all public facilities have full-time maintenance staff, or maybe it's the head of the school is also trying to oversee maintenance contracts. So they need something easy that they can really get them through the year. Built to suit spec office buildings. A lot of these clients that I've seen are very motivated to represent their own company's values. A lot of them are looking at operational carbon. They're trying to be leaders in their own way, stewards of the environment in their industry, and put forward that, hey, our headquarters is only using renewable energy, maybe has some other means by which it's sort of reducing its carbon footprint, be it embodied carbon. So that can be a big factor in why choices are made around parts of the building. At the same time, it's going to be where their best and brightest employees sit. So thinking about thermal comfort can really help that client understand, like, well, where do we might need shading devices? And then lastly, resiliency in operations. A lot of clients now are thinking about where's our power grid? Do we need to operate when the power goes down? If we do, what's that system need to look like? And is our building buttoned up and ready to be able to run at a low energy level? A lot of private developers I've worked with, again, they have all these same intentions, though it's really, they're in a business where they're trying to build a great asset for the right first cost. And for that type of group that I've seen, a lot of it can be motivated around modularity of use. This building might be a beautiful office building, though we need flexibility so different tenants on different floors can have different layouts, and it's going to evolve over its life. So there, it's really focused on, well, what's the right systems that can hit flexibility while also being affordable. We have to make the project and find tenants in a timely manner, so it becomes successful and profitable. It's an invention or a venture, right? And a big piece there can then be thermal and visual comfort, because if we're not able to really sell a building that is thermally and visually comfortable, it can be hard to attract the right tenant. So thinking about the values and the top values that your client might be weighing in their minds as they make choices can really then help inform what might be the right use of an energy model, and at which stage of design. So, thinking about the stages of bringing ideas together, designing and then building a building. Every project starts left to right with, we have all these different needs. We may have a schedule we got to hit, we got a budget we need to hit, but we also have different aspirations. We may want to bring great daylight into the space, make it very comfortable, and you need to start with this large amount of ideas and then work towards the convergence. Where do we find synergies in those, and eventually, how do we get that building built and buttoned up and delivered on time? And so when I then think about using energy modeling during that process, I always go back to what is it I am delivering. So actually thinking about the deliverable and who is the client that's going to receive this deliverable. So am I at a point where I'm making a presentation to an owner who doesn't know a lot about energy? Or am I working with an architect who I've worked with quite a bit and understands daylight metrics and energy use metrics and benchmarking? Or is this a utility program? Am I making a report for someone? Is this the permit set that needs to go in? So, what I'm delivering very much informs then what I need to do. So if we figure out what it is we're delivering, we then think about, well, let's outline the deliverable. What are the key info points we need to make? Is this a chart? Is this in cost? Do I just need a bunch of check marks against the things we know will make the building more comfortable? And really lay that out. Most times we actually know the direction an energy model will give us answers even before it's created. And there's an opportunity to storyboard that story and think, will this outline match the clients who will receive it? Is it 10 slides I need, or do I need one chart? Am I making a chart for someone else's presentation? That's also very common in energy modeling. And then ultimately that helps the modeler or whoever it is, the team that's working with the modeler, pick the right analysis method. What's the tool we want to use? How much time do we have to do this model to create the outline to make a deliverable? Do I have a day, a week, 2 weeks? Is this being planned for a permit set? All those things can then inform what the right level of, I would say, accuracy is and the right tool inputs are. So not every model has to be the most accurate model. Sometimes models are built just to inform the trade-offs between two things and really give the larger team an understanding of building physics. You got to remember that people that run energy models have much more interaction with building physics and building systems than most other people that design and create buildings. They all may know a little bit of that, but they don't spend their day in, day out studying that that side of our industry. So different energy modeling tools, all these tools can be used at every phase of design. Different tools I've experienced are better at different sides of this delivery process. I just threw these on here. I think when we work in projects, we do not generally tool hop, though I have in many instances used a very simple tool up front and then picked more of a full built-out suite of a tool to help create my permit model or help with some green compliance documentation I might need to do. So I am quite a big fan of doing that and thinking about ways to maximize the value of the team and maximize the value of the time you have. Sometimes making one model for all purposes is not the best way to maximize those things and really give the best advice you can to the designers that are creating this building. So just take that with a grain of salt. But these are just examples. If you haven't seen these tools or you work in a few of these and you want to explore others, where some might land. So I wanted to give two examples today. I showed three building sectors, but I'm only going to share about two. And I wanted to talk about my public education building. So this was a nature center that was up in the Pacific Northwest. It gets pretty cold. And the building from the beginning of the design said we want to be a net zero energy building. And we also want to, bring the right amount of sun into the building, get some passive heat, but we also, we don't want to blind people in the summer. It's going to be a classroom. We can't have too much glare. And so you can see just early on, even as the wing of the building was being formed, we were able to just take the mass and figure out where's the solar radiation, where could we put solar panels, where are we blocking the sun on that south in the summer, is that overhang deep enough to really reduce the glare in the summer. And this allowed us to then set an energy budget. If you covered the roof and solar panels wing to wing, how much energy could you make in a year? And what would that cost in terms of the number of panels? And we use that to sort of set a boundary. And so what we're looking at is each bar represents the energy use intensity of a building of this design, and the far right represents their PV budget that they set. We said at a high end, we could produce a 48 kBTUs per square foot of energy if we put a certain amount of panels on the roof. And that then allowed us to set one goal. And on the far left, we said, well, if we built this building to code, what do we think that energy use intensity would be? And then we worked that building through envelope enhancements, through system enhancements, through lighting enhancements to really drive the energy down, which gave a clear message, we can get to net zero energy. And now the question is, what's more cost effective? Can we reduce the amount of panels we have to buy? Can we make systems more robust and easy to operate at the same time? So trying to drive those two goals for this project team forward as best we can in a clear way. You have to bring the team along. You have to teach them about what this number means, what are these end uses, and how do they relate to them. I mentioned the climate was cold, and it's a classroom. There's going to be little kids in the building coming to learn about their environment and their ecology around them. So knowing that it's cold and knowing that the windows are a big driving factor both of the heating and how people experience that, we used this online tool that's made by some folks at Payette. It's this online shoebox comfort tool where online you can plug in a one room and you can say, I have this frame and this much glass and it's this temperature outside. And what the tool will help provide is a diagram that helps say, well, as you sit closer and closer to the glass or further away in this instance, at the line on each of these is shown at 3 feet from that glass. We can see that if we had a metal frame on the left, people would not be comfortable. They're sort of outside of the threshold where we want to be. And as we improve the frames or the thickness of the glass, we can get more and more people into the region where they should be comfortable, or we can at least reduce discomfort, in this case downdraft, that can occur on these cold windows. So this was just one way to sort of teach what are the drivers of cold discomfort and what are these options that they're actually pricing that we could then say have a different value to the user and the experience of the space. So my other example on the flip side, thinking about core and shell and spec property developers. So this was a office building, spec office building with parking below, where they are designing it and thinking about trying to attract tenants to this new sort of area where they could do business and this growing economy. And so here, we always bring energy use intensity to every project. A lot of clients already are thinking about that, but even if they're not, in the top left is showing this EUI for this building and thinking about some comparisons that can help weigh options and make sense. But really for this building, while we did start there and have that be a portion of the conversation, we very quickly pivoted to thinking about the risk in terms of the comfort of this building and how the comfort can then dictate flexibility, knowing that we want this building to be flexible. It's a core and shell office building. We don't quite yet know where the walls are going to go inside, how many conference rooms are going to be on what side of the building. And so what we're looking at are different analytical models where we ran a glare model, a very simple glare model of the massing, and we were able to look at the depth of where glare is a risk. So here we can see that the West right now, when we were working with the team, had a lot of glass and very high glare risk, which can mean that up to 10 feet of that perimeter has more limited flexibility in what you could do there um, on a floor plate. That might be fine, but it's also perhaps not something the owner was aware of, or even the architect was aware of. So trying to bring some numbers to these different designs can really help inform their choices and then enhance the skin of the building. Same information shown in a thermal comfort map on the right. This is just using, again, you can almost see each color zone depicts, we made a 5-zone model for one floor to really quickly assess, well, what's the temperature going to be of the inside glass, of the surfaces, what does the thermostat need to be set to, and right away you can see that this is the colors are frozen in time at one moment where the sun was on the west, but the little numbers on the left of the colored boxes show the whole year. So right now the design had 516 hours, or 12% of the year. It was too hot on that side during occupied hours. And with some enhancements to the glass, reducing the glass on the west, adding a little bit of shading, we were able to bring that number down to 131 hours, or 3% of the year. So still some hours, though a great improvement, right? An ability to now maybe use that space for more things than before. And the other thing I wanted to share was just also thinking about, it can be powerful to teach these analytical charts. What are they? How can they be useful? Though I would always encourage modelers to also bring pictures of real buildings that either they've worked on or they're familiar with. And so this is a picture of a real building where they had a lot of glass, and what they did was they used the programming of the space to say, well, that's fine. We're going to have a lot of sun coming in on one side, and that's going to be our corridor. That's where people are going to walk. It's a transition space. We don't think they'll be upset about the glare. They're not going to be standing there for a long period of time. Though you can now see I just added some basic measurements to this chart on the left, and we can see that's a 10-foot space that is now sort of set as their corridor. Even on the north, people often don't think about it, but the north sky can be a big source of glare. It can be very bright, even if you're not looking at the sun. The sky itself is bright. And so, again, using a corridor as a walkway to sort of reduce the amount of the sky that each person has to see out of the corner of their eye. And so there are ways, that was the right solution for this building. This can be a great building with this amount of glass. It doesn't always have to be that different strategies are one size fit all. It sort of matters what is the end goal for this building. Another thing we looked at in the same developer building very early on is bringing other quantities out of our energy model for the team to weigh. So, we know that the West is going to need more air conditioning if it does have a lot of glass. And so we were able to help translate what we're looking at as a peak day on the West and showing where those peak loads would be in a number that our mechanical engineer could understand, a BTU a square foot, and how we could reduce that as we reduce the glass down, 31 BTUs a square foot. And then for the owner and the folks that are pricing things, putting that into a number they can relate to. So this means you would have to buy 15 fan coils, and now you could buy 10 fan coils. They may just be able to understand the number of fan coils might be important. Here we put the capacity that we estimate those would be in round numbers. And again, this is early design. It's not that they don't have intentions of doing these things. You just have to remember that pretty much no one else on the design team at this point has actually built an analytical model of the building. They may be pricing systems based on the last job they worked on, and they may not have a sense of, is this glass going to need more air conditioning? And if they are, it's something like 10%. So you can bring some actual numbers to the table that can be very valuable to that team who is very driven by, again, making an affordable asset that meets their goals in the market. So those are my quick takeaways and thoughts. I think energy modeling could be a great area to work and a lot of fun. You end up being a professional translator of different metrics to different people, and really thinking about, again, going back to this idea of who am I working with, and who am I working with? What's their top motivator? They may want to see all the metrics under the sun, though being diligent with our time and effort to really maximize the value we can provide on teaching people about building physics, building energy and systems. So with that, thanks you everyone. And again, my name is Neil Bolcher. If you ever want to reach out or have questions or talk through any other ideas, my email is here. All right, thanks.